we're going to do 1.4, working on story problems and wording in those story problems. So let's take a look at write an equation for the following situation. So first off, they want an equation. So in that case, we need an equal sign, no matter what. Do not solve. Okay, so we just want to do setups. So we do not need to solve these problems. We're just going to try and set them up. So the first one, we're going to have 4. Okay. When I read story problems, I definitely read it left to right and just each word at a time. So if we can do something with just a word, let's do it. So 4 times. Now, here's going to be a interesting one that you're going to see a lot. It says a number. And anytime it's talking about a number, we don't know what that number is. But what we're going to do is we are going to put our variable. So our variable being x, or we could even change it because it says a number. We can make it the letter n. All right. And then our ever popular is always going to be our equal sign. Okay. And then as you read it, 56. 56. Now, once again, we have it set up, but we do not need to solve. It says do not solve. So we've got the setup, and once we have that, we're good to go, and we can move on to the next one. All right. Next, a number. So we go back to this idea of a number, okay? Minus. Now, there is going to be one time in subtraction where we have to pay attention to it, but it only happens here, okay? And we'll talk about that when we get to the less than problem. So if you see a number minus 15, okay, then we see is our equal sign, and then negative 12, okay? So read it, write it, don't overthink this, okay? The only one that's going to get confusing is when we have less than, okay? Because less than, we actually are flip-flopping. Because if you say 7 less than 10, what's 10? And we subtract 7 from that. Because 7 less than 10, we're really doing 10 minus 7. So whenever you see the less than, you kind of want to connect that together, all right? And we'll talk about that, but see, we have 3 times. Whenever we use multiplication, I always want to use the dot, okay? Now, here comes something tricky. The sum. So we need to add. And when we do this, what we need to do is think about doing the sum of something. So we want to put together 2 things. In order to do that, we have to do the parentheses. All right. So the sum of a number. And, so and is our addition sign or sum, or that's giving us our 2 things. So what are we summing? A number and 5. Okay. Is, all right, our ever popular is 45, okay? So it does not to say equal to, it could just say is. And anytime we see an is, that means equal. All right. So this one, what I would like you to do and get good at is saying, if anytime you see a less than, connect to the first piece to it. So we have 11 less than. So that means I'm going to do minus 11. Okay? It goes backwards. For that idea of 5 less than 8, we're actually doing 8 take away 5. So that's why. So we have 11 less than, so minus 11. And then we're going to do half. And yep, you're reading it. It just says a half. So that means half of a number. So our number is, remember, our variable. So our n. Then we get is. Negative 18. All right. So once again, setting these up, we do not need to solve them, but at least being the setup. All right, next one. Giovanni needs to raise $325 for a school fundraiser. He's already raised $210. Write an equation representing how much more money he has to raise. All right, so what are we thinking about? First off, do we have kind of a total? A total is the $325 Giovanni's trying to raise. We want that equal to what he's already done plus what he still needs to do. Because if he's already raised some money, come on, pick it. Thank you. He's already raised $210. So we know he's already got $210. But he needs some more because we haven't hit 325. So write an equation representing how much more money he has to raise. So we don't want to solve these, but this is how I would start by setting it up. Now, we could maybe rewrite it as we know he's got $325. We know he's already raised $210, so we could subtract that off. That's also an equation that represents how much more money he has to raise. But I think they're looking more, your teachers, and you can ask them, but they're probably looking for this idea more. Because that's the true equation, and then we do the subtraction property of equality to subtract 210 from both sides. But just in case, there are two different ways to kind of write this. All right, a pool is fenced on all sides. Right there, I'm thinking perimeter or area right off the bat because we're talking about fencing around it. And if we're talking about fencing around it, my guess is perimeter, even though I don't know what this problem is. So if 256 feet of fencing is required, what is the length and width of the pool? So yeah, once again, they want to figure out if I start here and go here and go here and go here, and they're telling us that's 256 feet, we can figure out what our width and length are going to be. How do we know that? Because the perimeter equals 2L plus 2W. 2 lengths plus 2 widths. Now, perimeter also could be just length plus width plus length plus width. You're just adding all of the sides together. And I want you to understand the length of it. They're writing it in terms of width, but that is the length. So, let's start with the first one, though. And let's talk about what the length is. The length is W plus 8. And what's the width? Well, the width is just W. So we're going to set this idea up. So when I see 2L, what I really am seeing is 2W plus 8. And when I say 2W, well, I know W equals W. But if it did equal something else like 3W, we would put 3W next to that. So you do kind of have to pay attention to what the W is. But in this case, it's just itself. So W. And then we can set it equal to the perimeter, but we do know the perimeter answer. What is, how much fencing do we have? We've got 256 feet. So we're going to set that perimeter equal to 256. I hope that makes a little sense. But some of the tricky stuff in any math class is having the prerequisite skills. So like if you didn't know the perimeter was 2L plus 2W, that gets confusing. What is 2L plus 2W? Well, we're taking all of the sides of the pool fence and adding them together. So there's a width, there's a length, there's a width, there's another length, there's another width. And just adding them all together. So it's very important that those prerequisite skills are there, and if you need help, that's okay. Ask anyone. They will help you, I promise. Any math teacher will help you because you need to know that stuff. All right, let's try these two. we are definitely going to make these a little bigger. Why? Because we can. Let's give us a little more space. See if we can get there. All right. Okay. So once again, let's just set these up. We don't need to worry about solving them right now. Just focus on getting them set up. One moving company charges $800 plus 16 per hour. All right, so we have move A, and another moving company, move B. Okay? Now, whenever you're doing this, what is the number of hours? Will the charge for both companies be the same? So we want to know when move A is equal to move B. So now we need to know what these are. So this is what we're looking for. What are the number of hours? Both is what will the charge be? Okay, so they are looking kind of for some solutions to this. So mover A, let's highlight this. So move A is going to be one moving company. And then move B is another moving company. Now, when we talk about moving companies, what we are going to get is an initial charge plus the hourly rate. And you're going to see this in a lot of story problems. This is a very popular style of problem. They're going to give you an initial charge, like cell phone policy. There's initial charge, and then there's a monthly charge, and then there's initial charge, then there's a monthly charge. Like, they do that a lot in story problems. So when we look at move A, the initial charge is going to be $800. Okay, so that's your down payment, and then monthly occurrences, we're going to do $16 per hour. So we'll label it H for hours. So we will say H equals hours worked. Okay. And we will label mover A as total cost. Okay. So we will have a total cost associated with this because there's going to be an initial charge and then some hours that we got to work out. What we want to do is see when both of these companies equal each other. Which one's going to help the other? Okay. So let's try move B. Move B is going to be the total cost as well. But move B's equation is going to be our initial amount, 720, plus $21 times the number of hours that they work. I guess I'll put a times up there. Okay, now let's do this before I get any farther. I'm going to throw this in between. I'm going to take this, cut it out, and paste it here. I think I'm not going to have enough room if I don't. All right. So a lot of this has been given information, but we're looking for when move A is equal to move B. So we want to set that up now. So I'm going to take mover A, which was 800 plus 16 times the number of hours, and we're going to set it equal to move B. So we're going to take that one. So now at this point, we're solving for a variable. So we're going back to last section's material. So we're going to draw a line down the middle of the equal sign, And then we're going to underline the variables. And when we do this, something very important is going to happen to us, because sometimes the highlights are on the same side of the equal sign, and sometimes they're on opposite sides. So if we draw this highlight and then we underline the variables, we can obviously more visually see that the highlights are on opposite sides of where the line is, that equal sign. Start solving this. So what we want to do, because these highlights are on opposite sides, we want to put all the highlights on one side, and then we're going to throw all the numbers on the other side. Okay, so we are going to subtract 16h from both sides. Okay, let's put that. Oh, I appreciate that. I will miss you as well. But like I said, I'm not good. I'm just a teacher. I want to help anybody and everybody that needs help in math. And I don't need to be in your classroom to still help you. You are more than welcome to jump on here at any time you want and get help. I schedule right now is Mondays from like 8 to 9 p.m. I started that almost last year. But feel free to jump in. Feel free to post questions in that Discord chat. I will answer those, and then I'll tag you in a TikTok video. Like, me being in a physical building, I don't need to be there. I can help you no matter what, okay? So, we are going to subtract 16h from both sides. When we do that, what we're going to do is 21 take away 16, and we're going to get, you got it, 5h. Now, what we are doing is what we call the subtraction property of equality. And if you want more help with this, please go back to solving for a variable video. We talk a lot about this, okay? So we're going to subtract from both sides. When we do that, what we're going to get on this side is 0 out these 16h's. So we are zeroing out the 16h because we want it to disappear. And that's what we did in this step, okay? So when we get from one step down to the next step, that's why you see that kind of justification there, okay? Now, this time we're going to move the 720 to the other side. So I'm going to change my color. I'll use, that probably, it's going to be terrible. So let me do this. Let me change the hue of that so I get a little darker green. Alright, so I want to, not there. I want to subtract 720 from both sides of my equation. And once again, this becomes a subtraction property of equality because we're doing it to both sides. So we're going to subtract 720 from both sides. Now, when we do that, why we're doing this is because if I do a positive 720 minus a 720, now I'm just left with the 5h. We have zeroed out the 720s. So that's why we're doing it. And I'll kind of try and do a dotted line to it. Now, 800 minus 720. That's going to get us to 80. And then, how do we get rid of a 5 times h? So what's the inverse operation of multiply? Yes. Divide. So division property of equality. All right. That's going to 1 out the 5s, which is kind of funny to say, but if I did 5 divided by 5, these don't disappear. A lot of math teachers will tell you they cancel out, but they're not canceling each other. They're actually forming just a single h. Because 5 divided by 5 will be 1. So they'll just get that single h. All right. And then we're going to do 80 divided by 5. So 5 goes into 8 one time. and we've got 3 left over, and 3 and 0 make 30, so 5 goes into 36 times. So it is going to take us 16 hours, so that mover A is going to be equal to mover B. So now what they're asking us to do is find out what that amount is. And remember, it's the equal amount, so we could put it into either equation and get the correct answer. We should get the same thing if we did this correctly. That's the reason we did it. So that move A is equal to move B. And let me show you this. Let's test this theory out. So mover A was 800 plus 16 times 16. Mover B was 720 plus 21 times 16. And let's show that these two amounts will come out to be equal amounts. So I'm going to grab my Desmos. And I got 800 plus 16 times 16. So 800 plus 16 times 16. And we get 1056, so 1056. I keep putting my pen down and I forget where I put it. Ooh. Don't do that. Move it back, please. Oh, no. Oops. Okay. That looks pretty close. So 1056. Okay. Now, next one we're going to do is 720 plus 21 times 16, right? 21 times 16. Okay. And that gives us 1056 as well. So we can do 1056 as well. And we show that mover A is going to be equal to mover B. All right. I am going to actually leave this one alone and let you try it. And then we'll do C, and then I'm going to do the same thing with D. So I can leave this here now because I'm not going to solve it all. So I'll just leave it so that you can see it and try it on your own when I'm done explaining this one. All right. So once again, vocabulary, prerequisite material, things that you need before I do it. Hit pause. Try this problem out. All right. Once again, prerequisite material, vocabulary, when angles are complementary. So we need to know what it means to be complementary. That's going to be the tricky thing. So if they're complementary, it means that angle 1 plus angle 2 equal 90 degrees. And we always, in my class, we did complementary, 90 degrees. Supplementary, 180. Complementary, 90 degrees. Supplementary, 180. And we repeated it over and over and over. Because I go complementary, and they go complementary, 90 degrees, 90 degrees. So repetition, the more you can practice this, anytime I write it, complementary, 90 degrees. Supplementary, 180. Now, in this problem, you actually didn't even need, they gave you the definition, okay? So they're helping you with that prerequisite material. But just good practice in knowing that kind of vocabulary. So the two complementary angles have a measure. So we have a measure of angle 1 is going to equal 2x minus 10. And then the measure of angle 2 is going to be 3x minus 10. And both of these are given. You can see right here that they gave us that one. And then right here, they gave us that one. Okay? Find the measures of each angle. So they do want us to find them. So once we know what x is, we can just substitute it in. and solve it out. Okay? So let's do some justification that we got. So we have the definition of complementary, because the definition complementary means the two angles added together equal 90 degrees. Now, how do I know that the measure of angle 1 is 2x minus 10? How do I know that the measure of angle 2 is 3x minus 10? Is it always going to be that way? Is every single complementary problem going to have a 2x minus 10? Does that make sense? Well, no, they could change that up at any time. So what you need to understand is this is given information. They have to tell you in the problem this information. If they don't, you can make up whatever you wanted. There's infinitely many things you could plug in. So they have to tell you some stuff to give you a specific problem to solve. And that's what they are doing there. They're giving you those two pieces of information. So now, once they do give you the measure of angle 1, we can just drop it in right here for angle 1. And then the same thing goes for angle 2. I was really going to highlight it first because I already had it, but I'll let it go. So when we see the measure of angle 1, what we're going to do is plug in 2x minus 10 plus something equals 90. And that something is going to be the other piece. So that other piece is 3x minus 10. So all we did is we replaced angle 1 with angle 2 with what their measures actually were given to us in this problem. Okay? And this is what we call substitution. We're substituting these given pieces of information into a general formula that is always the same. Okay? So, when we do this, now we're going to play our game. Underline, underline, draw your line down the middle of the equal sign. This is solving for a variable, going back to 1.3. So, are these highlights on the same side or are they on opposite sides? So when we look at this, here's our highlight, and you can see is both of them being on the left side of our problem. So that means all we need to do, combine like terms. Anytime they're on the same side, we're always going to do combine like terms. So 2x plus 3x. So we're going to do 2 and 3, add them together and get a 5x, okay? And then we can do minus 10, minus 10. So if you lost $10, then you lost 10 more dollars. What's actually happening is you losing $20. And then we can bring our 90 straight down, okay? So combining like terms, that's all we did. Now, we still need to underline, so here's our highlight. Now we only have one highlight, so that means we need to get rid of the numbers that are on that same side. So I've got a 5x and then minus 20. But I've got a 5x minus 20. So that tells me that the minus 20 is what needs to go first. So we're going to add 20 to both sides. And the reason it goes first is because it's the farthest away from my variable. When I say 5x minus 20, it's the farthest thing away from my x. So that's what I got to start with. I've got to start with things that are the farthest away. Now, this goes back to the addition property of equality. So we're going to do something that's the same on both sides because we are going to zero out those 20s. Because 20 minus 20 or negative 20 plus 20, those are all going to cancel and zero each other out. So that all I'm left with is 5 times x equals 110. So now I can do my division property of equality. So I'm going to do division property of equality, because I'm trying to get rid of the 5, and 5 divided by 5 gives me a single x. So I'm going to 1 out the 5s. And then I'm going to do 110 divided by 5, and that's going to be 2. And that's going to be 2, and the answer is going to be 22. So 22 is my x, but the question asked me something else. Find the measures of each angle, and I have not done that yet. All I did was find what x was. So we're going to go back to the measure of angle 1, and angle 1 is 2x minus 10. That was given. But now we have something to substitute into that problem. We know what x is. What is x? X is going to be 22. So now I can take the measure of angle 1. I can do 2 times 22, subtract 10 from it. Oops, that's not given. That should be substitution. And actually get what the measure of angle 1 is. So, and you don't have to do this. So I did multiplication. Then I'm going to do subtraction. If you wanted to go that route, you can in when you're writing proofs, but really you could just do 2 times 22 minus 10 equals 34, and you could just say simplify. So once I do that, I get the measure of angle 1 to be 34. That's great. I'm still not done though, because I need the measure of angle 2 now. And the measure of angle 2 is 3x minus 10. So that x pops up again. We know what that x is though. So this is given. And we're going to do substitution, because I'm going to put my answer to x into this equation. So 3 times 22 minus 10. So that's going to be 66 minus 10. And then the measure of angle 2 is going to be 56. So I did multiplication, and then I did subtraction. Now, if I were to take these two, hopefully when I add them together, they better equal 90, because that's what we initially started out with. And that's how we can get those answers. So a double checkpoint, we could do 34 plus 56, and shows that it does equal 90. All right. That last problem is up there about renting a car, but I'm going to leave that to you and do your best, okay? Think about that kind of $25 per day plus 15 per mile. Something about that. All right. I appreciate everyone that stopped in today. I hope you have a blessed week, and until the next video, but have a wonderful day.